data structure series. Today we are going to talk about an important data structure in computer science, the singly linked list. Yes, a linked list is a linear data structure in which elements are stored as nodes. A linear data structure is one where elements are stored in a sequential fashion. Here, each node stores two compartments. One is data and the other one is the address of the next node. Unlike arrays, linked list elements are not stored in contiguous memory locations. Nodes can be located anywhere in memory and are connected by means of a pointer. Look at this example. The nodes contain values 10, 20, and 30. The arrows represent the addresses connecting one node to the next. Note, the final node points to null, indicating that this is the end of the list. Exactly. Right. Everyone would have played this game, the treasure hunt. At each location, you will have two things, a clue and the direction to move to the next location. You can imagine this clue to be your data and this direction to move to the next location as your address. Yes, this is exactly how linked list works. Look at the example of the linked list. There are nodes 1, 2, 3, 4, and 5, where each node has two compartments, the data and the address. Fine. The last node address is null. Yes, before understanding why linked lists are so useful to us, we should understand the problems with arrays. Suppose we have an array containing say 10, 20, 30 and 40. If I want to insert 25 between 20 and 30, all the elements after 20 must be shifted one position to the right, is it not? For a smaller array, this might seem simple, I can do it. But what if my dataset is larger? Repeating shifting operations like this becomes very inefficient and time consuming. So this is one of the major limitations of arrays when frequent insertions or deletions are required. So what if I use a linked list here? Yes, the linked list solves this problem very efficiently. Consider a list 10, 20, 30. If I want to insert 25 between 20 and 30, I need to simply create a new node and update the link. The structure then becomes 10, 20, 25, 30. No elements are being shifted, only the pointer connections are modified. This makes insertion and deletion operations much more efficient when compared to arrays. Yes, I definitely need to talk about this important pointer variable called the head. The head variable stores the address of the first node. Look at the head node, the variable. The address of the head is 5000. The value stored in the head is 1000. So this 1000 is the address of the first node. Look at the first node. The data is 10. The next is 2000, which is the address of the second node. The second node is the last node in the list. So head is equal to 1000, which is the same as the first node's address. Ampersand head is 5000. So the value stored in head is the same as the address of the first node. Done. Moving on to the type of linked list. There are different types of linked list used in programming. The most common types are singly linked list, doubly linked list, circular linked list. Singly linked list, each node points to next node. Look, we have already seen this example. A node is being divided into two compartments. One is data and the other one is the link or the address part. The last node always points to null. Doubly linked list, each node contains pointers to both the next and the previous nodes. Look into the example. Each node contains three compartments here. The left compartment or the first compartment is a link to the previous node. The middle is the actual data and the last compartment or the third compartment is a link to the next node. Very importantly, the last compartment or the third compartment of the last node is null because it is the last in the list, and the first compartment, that is the link to the previous node of the first node, is null because it is the first node in the list. Circular linked list, last node points back to the first node. So each node points to the next node and the last node points back to the first node. It is not null here. So in today's presentation, my focus is only on singly linked list. Right. To implement a linked list in C, we first define a node structure. The node structure contains two members. The first member is an integer variable called data, which stores the value. The second member is a pointer called next, which stores the address of the next node. Using this structure, multiple nodes can be connected together to form a linked list. Look at the example. The node structure has two compartments. One is the data that stores the value, and the next is storing the address of the next node. Done? Yes. Right. So, I have seen many people writing the structure definition as this, right? So let us examine this node structure once again to keep things much clearer. The declaration struct node star next is extremely important since next stores the address of another node. It must be definitely declared as a pointer. If you write struct node next instead of struct node star next, the structure definition becomes invalid because it would recursively contain itself. Therefore, always use a pointer to refer to the next node. Right. Moving on, let me create a node. Now let us see how a node is created dynamically. This is how. I use a create node function which allocates memory using malloc. After memory allocation, the given value is stored in the data field. The next pointer is initialized to null because the node is not connected to any other node yet, is it not? Finally, the function returns the address of the newly created node. This approach allows you to create nodes dynamically during program execution. Right. Fine. Let me try creating a singly linked list with 3 elements. Right. The nodes are assigned values 10, 20, and 30. Next, I try to connect them by setting node 1 points to node 2, node 2 points to node 3, and node 3 points to null. This is forming a linked list 10, 20, 30, and null. To display the list, a temporary pointer traverses each node until it reaches null. So it prints the data values all along the way. There might be a question. What if I need to create multiple elements, 100 elements, 1000 elements? Yes. This example demonstrates how linked list can be created dynamically inside a loop. The loop runs from 1 to 100. Yes. For every iteration, look, memory is allocated for a new node and the current number is stored as its data. If the list is empty, the first node becomes the head. Otherwise, the new node is attached to the end of the list using a temporary pointer. After all iterations are over, the linked list contains values from 1 to 100 connected sequentially. Finally, the traverse list performed to print every node until null is reached. Yes, a singly linked list is so powerful. It's a dynamic data structure made up of nodes that are connected through pointers. It overcomes the insertion and deletion limitations of arrays by modifying links instead of shifting elements. In this video, we have learned the node structure, the dynamic memory allocation using malloc, creation of a node, linked list construction using both manual linking as well as loops. Understanding linked list is very essential because they form the foundation for many advanced data structures such as stacks, queues, trees, and graphs. Stay connected. Any doubts, post it in the comment section. Happy learning. Thank you.